Example 2. Add expressions with more than one variable. Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So we're going to have to look over here at the sign because the sign usually gives us additional information. First of all, what we know is that Cindy is selling each muffin for $2.40. So let me change my pen color there, make it easier to see. Good. All right, so $2.40 times M is the amount of money that she is earning for each muffin that she sells. However, it tells us in the problem that she spent $125 on ingredients for those muffins in order to make them. So we're going to subtract $125, which is the cost of those ingredients. So here's the first expression. Then we learn that Cindy spent $92.40 on the bagels, okay, on those bagel ingredients. Okay, that was here. And we see that her income from selling the bagels is $1.80 each. So $1.80 times B for the number of bagels that she sells is going to tell how much money she makes on those bagels. But remember, she had to buy the ingredients first. So we're going to subtract $92.40 from that total amount that she made because that is the cost of her ingredients up front. Now what we're going to do is we're going to put these two expressions together and we're going to look for where we can combine like terms. In these two expressions, we are still going to add them together by adding each expression. So I've got parentheses around them, and you see that we have $2.40 times M minus 125 that represents the amount that she makes on muffins. And then we have $1.80 times B minus $92.40, which is the amount of money she spent on the bagel ingredients. And we're going to add these two expressions together. What you should notice is that we have different variables. So in the first expression, we have an M, and in the second expression, we have a B. We cannot put those terms together. So we leave, oops, wrong color, sorry. Let's erase that. All right, let's go back to my red pen. There we go. Okay, so let's leave the M term alone, and then we're going to leave the B term alone. Next, we want to find out how much did she spend altogether on the ingredients for the muffins and the bagels. So that's this part right here where we combine together the cost for the muffin and bagel ingredients. And when I put those two terms together, I get negative 217 and 4/10. So what this means is that in my expression, Cindy is going to make $2.40 on each muffin, $1.80 on each bagel that she sells, but she has to subtract out $217.40 that represents the amount of money that she spent on the ingredients. Now remember, you cannot put together the cost of the muffins and the bagels because those are different variable terms. Now let's check out example 3 and some more complex expressions. This is where we have some try-it questions. So you may need an extra sheet of paper. As we complete the try-its, we'll do those together, but you'll notice that in some cases you have fractions, and those may need a little bit more space because of the common denominators that we'll need. But let's take a look at example 3, since this one is already solved for us. Add the expressions 1/2 x minus 3 minus 2y plus 1/4 x minus 2y plus 5. So we're going to be using our commutative and associative properties to reorder and group together our like terms. So first we're going to pick out the terms that are similar. In other words, terms that have the same variable. So here we have 1/2 x and 1/4 x, and you'll notice that those terms are put together here. Then we have our terms with y. We have negative 2y and negative 2y. So here are those terms right there. And then we have our constant terms, and our constant terms are just the numbers. We have negative 3 plus 5. And those two terms are in the last part of that expression. Now we're going to combine those like terms and put the pieces back together in one final expression. So the first thing that we have to do is add 1/2 x plus 1/4 x. And in order to do that, we need to get a common denominator, which in this case will be fourths. So the good news is I don't need to change the second fraction, but I do need to change the first fraction from 1/2 into 2/4. So now I have 2/4 x plus 1/4 x, and I get 3/4 x. Then I'm going to put together my terms that have a y, and I have negative 2y plus negative 2y. And I'm going to just put those coefficients together, and negative 2 plus negative 2 is a negative 4y. And then last but not least, I'm going to add my numbers together. I have negative 3 plus 5, and that equals 2. So my final expression when I add these two expressions together is 3/4 x minus 4y plus 2. So I've just taken those three pieces and put them all back together into the expression. Now we're going to go down to the bottom of the page and attempt your try-its. For A and C, you can probably do those directly on your paper as is. With decimals, it's a little bit easier because we can use our calculator to actually do the computation. For each try-it, we are asked to find the sum. For try-it A, the first thing that we should do is try to identify if we have like terms and where we can put like terms together. So what I notice first is that I have a variable term, 9 7/4 c. I don't have any other terms that have that common variable with it, so I know that 9 7/4 c cannot go with anything else. Then I'm going to look for another variable term, and I do have one right here. I have a negative 5 48/100 p. And again, there is no other term that has the variable p with it, so I know that that term will not get combined with anything else. And last, I look for constant terms. In this problem, I have a negative 250 50/100 plus 185 70/100. So I'm going to need to put those two constant terms together. So as I look at my final expression, I know that my terms that cannot be combined together are simply just copied into my answer. So I have 9 7/4 c minus 5 48/100 p minus the combination of my two constant terms, which gives me a negative 64 8/10. So that is the simplified expression that puts those two expressions together. Next, we're going to go on and do letter C right below this because we are going to move this paper over so that we have plenty of room to do the fraction questions on the other side. So let's go down here and take a look at letter C. Again, we have decimals, and again, we have both constant terms and we have variable terms. So let's first look for variable terms. The first variable term I see is a negative 14 2/10 b. I don't see any other terms that also have the letter b with them. So what that tells me is that term will simply just be copied into my answer. And that's a b, not the number 6, so be careful how you write that. Okay, next I'm going to look for any other variable terms. And I have 6 76/100 d, and I have a negative 3 4/10 d. So I'm going to be putting those two values together. The term that has the d on it is going to be a positive 3 36/100 d. Then the last, I'm going to look for my constant terms. I have a negative 97 35/100, and I have a negative 118 7/10. And when I put those two terms together, I get a negative 216 5/100. So my simplified expression is negative 14 2/10 b plus 3 36/100 d minus 216 5/100. Okay, so now let's take a look at letters B and D on these try it questions. So I'm going to move and slide my paper over. So you're just looking at parts B and D. Okay, and hopefully I've got a lot of white space left on my whiteboard here. If you run out of space on your paper, then please use an additional sheet of notebook paper to write down these questions and their solutions. In part B, we see we have fractions, but our strategy does not change. So we're still looking for variable terms that we can put together. So I see that I have two terms that both have x with them. So I'm going to do the operation 2/11 x minus 3/11 x. And I'm just computing with the numerators 2 minus 3, and I get a negative 1/11 x. Then I look for any other variable terms that I have. I have a minus 5y, and I have a plus 5y. And what do you notice about those two terms? They're opposites. So we have a negative 5 plus a positive 5, which makes 0y. In other words, we don't have a y term anymore. This one disappears. Okay? So we don't even have a y term to put in our answer. And then last but not least, we're going to use, I'm going to use my green pen here to underline the other portion of this, which is in green for our constant terms. We have negative 3 plus 5 5/10. And negative 3 plus 5 5/10 is how much? Use your calculator to check. You should get a positive 2 5/10. So our final expression is negative 1/11 x plus 2 5/10. That one wasn't so bad. Now let's take a look at D. D is the last one, and I notice that there are multiple fractions, and none of the fractions have common denominators. But before I freak out about that, let's go ahead and start collecting our like terms, because we only need to get a common denominator if we are adding or subtracting fractions that need a common denominator. So the first thing that I see in terms of variable terms is a negative 1/6 m, and I'm going to put with that a positive 7/10 m. So negative 1/6 m plus 7/10 m. And by doing that, I need to get a common denominator for 6 and 10. There are lots of denominators that will work here, but the one that works first is the denominator 30, because both of those can be made into 30. So it's 6 times 5, which means I'm going to do 1 times 5, and I get negative 5. And then it's 10 times 3, so I'm going to do 7 times 3 to get that common denominator, which makes 21 over 30m. So what I'm actually adding is negative 5 plus 21, and I get 16/30 m. And then, of course, I can simplify that because 16 and 30 have a common factor. Okay, I can divide both of those by 2, and I get 8/15 m. So my m term in my answer here is going to be 8/15 m. Next, let's look for other variable terms and see if we can put some other things together. I have 5t and I have a 9t. So 9t and 5t together makes 14t. Easy part is I didn't have to get a common denominator at all for that one. And then last but not least, I have some fractions. I have the fraction 3/8, and I'm going to add to that 1/4. Well, I don't need to change the 3/8 because I can make the 1/4 into 2/8 by multiplying both parts by 2. And 3/8 and 2/8 makes 5/8. So my simplified expression is 8/15 m plus 14t plus 5/8. So I know that that seems nasty because of the fractions, but they're really not so bad as long as you take them a piece at a time. So collect your like terms first, and then worry about whether or not you need to get a common denominator. Now let's go and try some questions on the practice and problem solving pages.